So in today's episode, I'm actually going to break out a tape measure.
Again.
So click subscribe, like the video, comment below, give me some feedback, do the entire YouTube thing. And
you heard this whole intro yesterday. This is part 2. If you haven't seen part 1, go back to my profile, check it out. That'll get you caught up to where we are today, and let's just get at it. So this is where we left off yesterday. We're going to dive right back in, drop the layers, make the axle and the wheels disappear so that we can get at the frame rails. This is the coolest part of it all for me. This is where we start to make, right now we've got an outline, we know what we want it to look like, but the plates that we have, they aren't going to be structural, they're not complete. This just doesn't work yet. So having all my views up on the screen is super handy. I can rotate a view and I can look at multiple things at once. I can see things from every angle. I can see exactly what I need to do. As I'm going, some of this is just, historically, I know what I'm doing. In this case, I know I'm going to need a cross member at the back, something structural to hold the frame rails. I go back into my solid tools. I select box, corner to corner, and height. Our corner, our width is 2 inch, our 4 inch is our height, and we select the inner dimension of the frame rail as our length since we started on the other side. We're doing the same thing in the front here. 2 inch wide, 4 inch tall, select out to the opposite frame rail, and it drops a box tube in between. Now, this does nothing except visually remind me that I do need a cross member front and rear. In the front, I'm going to have to worry about rad clearance, so, this may change. This is more just a placeholder for in my head. I decided that it was a little too close to the crank pulley, so type in move. My start point, drag it sideways. You can either click in a start point and then move it somewhere, or if I wanted to move it 2 inches, I click the start point, which is anywhere on the screen. I type 2, I hold my mouse off to that side, the direction that I want it to go. I hit enter and click the mouse and it moves at my 2 inches. It makes it super simple. So what I've done here is I've brought the axle back into the equation here. I've thrown it in. Now, something I've noticed all along here, in reality, this axle, if you look at this model, is through the middle of that frame. Now, when I put my tires on, the tires are not going to be perfectly round. The low side is going to sit low. We want this to basically sit frame rail on the axle tube when it's aired out. I know that interference may be a problem, and the box tubes that I put over the axle, when I'm assembling this frame, if I decide that it's not quite enough, I can make the box tube a little bit longer. I can adjust those pieces. I'll still have all my same curves, but I can take advantage of the space depending on what my body will take. These are things that I can do on the fly as I go. What I'm doing here, it doesn't change any of that. If I have to extend the box tubes, I know I can do that later when I get into real world scenario. If this was something that I was building for somebody else, I'd make sure I took this into account. But in my case, it's easier for me to get this done quickly and show you how it all works. When I build the frame, I'll go back in and I'll show you if I extended this. I'll reference back to my drawings. And I'm pretty sure my frame's right, and the tire is wrong in my case here, but we'll see what happens when this plays out in real life. I also know that I want a cross member over the top of my axle. There's going to be a lot of strain up here. I'm going to have airbags. I'm going to have shocks. I'm going to have things going on in the back here. Now, I can't run a cross member straight across because, as you can see, my diff comes into the space occupied between the frame rails. So what I'm looking at here is actually putting in a bent tube cross member. Now, the cool thing is that with my lines, we have a pipe command, and I can actually turn a line into a piece of tube. It allows me to move all my points. That's the place, the highlighted line is the spot I want it to land on the frame. The outer line is where I believe it will clear my diff, and that angled line is where the tube would have to go. So the initial line that went frame rail to frame rail is just one we're using for reference. The line on the outside there, that's what I want it to be. So I drew a line where it looks right. I mirrored it off a good known center point. This gave us our equal on both sides. We've gone and I've used a trim tool, trimmed out the rest of the line. I'm going to go in. I know that my die in this case is a 6-inch centerline radius. This is a known value. Your bender may be different, but 6-inch centerline is what the die is that I'd be using for this. So I selected 6. We created our radius. I joined the whole line together into one piece. Actually, I haven't joined the line into one piece. I am just checking to see if that tube is going to hit. In this case, I know that tube needs to be longer because it hasn't gone all the way through the frame rail because it's on an angle. This is the beauty of the CAD, is I can actually go through and change all of this. This changes quite a bit when I'm doing tube work. I can manipulate these lines all the time. This is quite literally, this isn't sped up. This is real time, what you're seeing on the screen. So this is how fast these changes can be made. And the beauty of having multiple views, and we've got top, side, rear in this case, and a 3-dimensional view that I can move around, is once I've got this line connected, the radiuses is done. I've used the pipe command. There's a tube command as well. Pipe is the one we want for this. Don't ask me why. I just know that this works and tube doesn't. So I use the pipe command. I type in my diameter or my radius. Radius is half of the diameter. So I type in my diameter of 1.75 inch, which would be 0.875 if we're talking about radius. And I create a tube, and the beauty of it is that we look at that 3D view and we know that it clears the pumpkin. We've probably got about 1.5 inches of clearance all the way around it. And if we go to the side view, we can see that this is below the package tray area. I know that this is going to fit how I want it to. So that allows us to use that as a guideline, and we're going to move on to something else here. Whether or not that tube goes exactly there, who knows? But I wanted something that I could work off of, make sure it works. This car is going to get a roll bar. I want a stiff chassis. So what I'm doing here is the best place to attach a roll bar is right to the top of the frame rail. We know that frame rail is within the body because it's just inside of the rocker, which means I can land a tube on top of this. I can either attach the cage straight to the frame and cut my floor pans to clear, or I could put flanges on top of the floor inside the car, weld it right in. What I'm doing here is I'm gauging where my roll bar should be, in my head. This is where it works. I can run my vertical bar. I can mirror it off of our center lines that we dropped earlier on, connect them with a line between them. I'm using the radius tool here, back to the 6-inch center line radius, create our radiuses. We're going to join those lines. Now you can select all kinds of stuff. It's only going to connect or join the lines that are connected. But you can see here, selecting these lines, we're going to type in join. That makes one line. We're going to use our line tool again. Now, the reason that I haven't put an extrusion on this is because I want to figure out where the back braces are going to be. A roll bar is useless if it's not connected. So this cross member here is the perfect place to do this. Now, normally I'd want an X behind the seats. There's not room within this cab for that. So I'm playing with the idea of an X here. So what I'm going to do is I'm going to connect from the roof here down to the crossbar that we put in. I mirror that line, that gives us our X, and I'm dropping a control point right on the center of the X, because the control point can be seen from the side, whereas our X can't. See my cursor circling it there, that X is there, but that means that X, that crossover point, is basically at the bottom edge of the window, those bars are going through my rear window, which is already far too small. So in this case, I decided that I'm not going to do a crossover. It's just not going to fit in what I want. So we're going to run these bars down and out to where they clear the back window. It's tied into that cross member. I know that we're safe. Again, this is just a visual. In all honesty, when I make these, I'm going to stand there with a piece of tube and a tape measure. I'm going to get a rough measurement. I'm going to notch one end. I'm going to drop it in. I'm not going to mark it with a Sharpie. I have access to a CNC tubing cutter, but in reality, since I'm bending these pieces by hand to fit the frame rails, it's not the approach I want to take on this. I can cut the tube faster with a grinder, notch it by hand, than it would take for me to program it all out. This isn't anything I'm going to be reproducing, so there's no reason to make it reproducible. When I'm putting this all together, I'm trying to visualize where the load is getting transferred to. The doors are going to have suicide hinges on them. That's already a given. That's something I've decided. So I want a bit of a door bar to tie it down, kind of looking at the levels back to our multiple views. Obviously, I know that, that's about the level that I'd like the door bar to be. It's not going to interfere with my arms too much, and I want it to land in the center of the frame again. So what I've done is I've just pulled a line straight forward from the rolled bar. I've pulled a line from that line down to the edge of the frame, move it to the middle of the frame, and we radius it, and we now have a bent center line. Again, this will go back into the pipe command for this, but first we're going to get rid of these tubes here, these extrusions over our lines, because I know that I want to connect that back. That door bar isn't going to be very good if it's not tied into anything. So the strongest thing you can do is connect tubes to a node, which is a spot where multiple tubes meet. That's going to be your strongest place. Where I'm connecting those tubes there, it's going to be really easy for me to gusset that directly down into the frame. All of those tubes, they're going to be under the floor. There's no reason for me not to weld this directly there. I can flange it further up if it's going to get flanged. Realistically, what I'm probably going to end up doing is only flanging the door bars. Everything else is going to be welded directly to the frame. This is just going to bring a lot of rigidity to the chassis. For what I want to do with this car, it's going to work well. But as I'm speaking here, you can see I'm just selecting one line at a time. I select the pipe command, my diameter, and I hit enter. It'll ask for the end diameter. I hit enter again. We can see here, I was talking about earlier that the tube doesn't go far enough. I'm just kind of pointing out visually when I bend these tubes in real world situations. I always leave myself a little bit of extra room. So I'll probably leave 2 inches, 3 inches on the end of that tube anyways. And then I can cut it to fit just in case real world isn't exactly what it shows on my screen. But the cool thing about the CAD software is the last known command, if you right click the mouse on nothing, it will actually do your last command. So if I click on a line, click the right command, it automatically does the pipe extrusion on that line, and saves a lot of typing. Meanwhile, what I've done here while I'm discussing tubing is I've actually selected the driver's front frame rail, and I've moved it out of the way of the rest of the drawing. I've just selected everything that I'm working with. I usually move things 100 inches out of the way, make sure that I can see it in every angle that I need to see it. I don't need to see this front to rear, so it doesn't interfere, but the other 3 views I'm going to use quite a bit here. I know that everything I do on one side, I'm going to mirror to the other side. So what I'm starting with here is I've selected our piece of plate, and I know that I need a weld seam around that plate. So that plate that runs between the box tube, I want 1/8 of an inch gap all of the way around it. So I've selected our outline, and I've typed in offset, and I can type in my offset dimension, in this case 1/8 of an inch or 0.125, and I've offset it in the 1/8 of an inch. Now it doesn't touch that. Now I've selected all of my box tube, and back to even numbers, I just move it up 10 inches out of the way because I need my box tubes for my drawing, but I don't need them for what I'm currently working on. Now when you're building a frame like this, the biggest thing to worry about is structure, and normally what people do is they'll build it out of box tube, they'll miter the cuts, and they'll build fish plates. What I'm working on at the moment is I want my fish plates to be internal. Since I want the frame to look mandrel bent, the side plates will show the profile of the tube, and my upper and lower plates will actually be formed to the radius of the plate that's on your screen. Now, because of that, I have the capability to weld fish plates to the inside of the box tube. I can weld my outer plate on top of that plate. I can plug weld everything, and then I can weld everything inside of there from the openings, and then I can basically put my top and bottom plate on top. I'll leave it a nice corner to corner weld and leave it room so that I'm not grinding my weld all the way off. And we're going to end up with a piece that, you know, if obviously it's not mandrel bent from a distance. Once it's cleaned up, it'll give the illusion that it is. And at all of my radiuses here, that means I'm doubling up my strength. Everything's going to be quarter plate, inner and outer. It's just going to get stronger. Now, because I want to be able to weld things, my inner fish plates, I'm actually going to offset my outer plates again. We're going to offset them another 1/8 of an inch to give room for weld. And I've designed, you know, a little circle here with a couple of legs going out. They go out to the points of my plate, copy it from one side to the other, and then I purely have to rotate it around the point and everything meets up. That means that they're mirror images of each other off the ends. I can go and select my trim tool, select the lines that I don't need anymore, and what I'm left with is my inner fish plate. Sometimes this process is a little tough to describe because obviously there's a whole lot more going on in my head than you get to see here. I've been doing this a long time, so I know kind of what I need to do, and trying to explain the process, it's and this is interesting for me as well because this, like I said, this is not something that I normally do. So now what I'm looking at here is I separated my end piece there, and I'm going to rotate this around. We're going to copy it to the end there because that corner is going to need the same inner fish plate, and we're going to rotate this around, and because right now I copied it over to the wrong corner, so we're just spinning it around. I'm going to move it from the point down. I'm going to rotate it again, and basically we're checking his interference here. I know that I want a plug weld hole on the inside of the frame on my inner fish plate. Normally this would be on the outside, but in this case, because of what we're doing, it is on the other side. Now, looking at that, you can see how everything overlaps there, and honestly, it just doesn't make a whole lot of sense to do it this way. I looked at this, and by the time I got my plug welds together, I mean, the piece kind of tapers weird in the middle. So I'm going to take this whole piece an entire step farther. We're going to go back up to our line tool, and I'm just going to connect these inner fish plates. We're going to do away with those shapes within that short piece of tube. And this is a section that I know not going to change. It's not like the rear axle. This one here, it is what it is. So I know that my inner fish plate, I can get rid of that. We're going to take this piece here, and we're going to rotate it out. Same thing as I've been doing all along, and sometimes, you know, the explanation just beats out what I'm working on here. I managed to put this one on the wrong spot. It happens sometimes. It just grabs a control point elsewhere. So we're just going to rotate this one around now. We rotate it out, and now my fish plate matches the other end. For whatever reason, this end came out slightly different. I think it's because that piece is actually cut on the radius. I didn't get onto the straight section of tube with that piece because of how short the frame was, but it's still going to serve its purposes just fine. So the highlighted area will be the fish plate that is inside of the frame rails. the black sections are the outer skins of that plate. Now my inner fish plate will have holes to plug weld to the outer plate, so I'll be able to assemble these two pieces out of the car. Once these holes are in here, you're never going to see them except for heat marks on the outside, which will get painted over. So me trying to center up this circle here, really, it's just me being OCD again. I over obsessed about this for a moment. You know, I go in and I figure out where the center line is, and we can take our line tools. I drew from the middle of the curve to the middle of the curve. Now you can do a curved line tool with control points. I'm selecting from the center to the center to the center, and if we figure out where the center line is, we can actually take this control point and we can move that up. You can see when I highlight over this, that's where center is. It snaps to that due to the controls within the software. So I know I want to bring that line down a little bit. Now, obviously this isn't exact, but I just wanted to kind of get it a little bit closer for my own peace of mind. I select the center, move it from the center of the circle, click it onto the line. It gets a little more centered. Like I said, this is just busy work for me that didn't really need to be done, but I did realize that these plug weld holes were a little bit too big for where I had them. I was much happier bringing it from 2-inch down, and since I know this radius is the same, all I did was mirror the plug weld across that line. That gave me my plug weld hole, and we're going to take that circle and we're going to put another plug weld hole in the middle of this one. This one just needs one, but of course when you're using the commands, I use the circle command and it automatically went to the same size circle as I used the last time, instead of offsetting what I did on the other one. So delete that one, put it all together. Now I've selected everything, and if I touch the control key, I can unselect pieces, and I'm going to group these pieces together. That way from now on, when I move this piece, wherever I move it, those pieces stay together. Super handy when you've got pieces of plate you're designing in multiple planes, because you don't worry about moving your holes with the wrong piece. Now I've selected both of those tubes we talked about earlier, and you can't use the join command on solids, so you have to go into solid edit tools union, and it will actually join them into one piece. So now what I talked about in the first video, being able to select them separately, we can no longer do that. Now, if you remember in the first video, I explained that the frame rails that I made are solid. They're solids. They didn't need to be hollow box tube for our purposes, but in the front, for what I'm currently doing with the fish plates on the inside, having a hollow tube is actually beneficial to show where all these pieces go. Now I can take my solid here and I can create another solid. In this case, since our box tube is going to be 2x4/8 wall, we can create a box tube that's 1 3/4 by 3 3/4. We can start it on the point, move it in 0.125, up 0.125. Now that box tube represents the empty space. I've made this oversized so it extends beyond, so that I guarantee, but what I'm doing here is I'm copying that same box tube to each of the other pieces of box tube within my frame rail there. In the middle piece here, we'll actually end up copying it from that box tube down to the middle box tube, and then we'll have to rotate it. But if I select the box tube we want to keep, our original, if I go into solid edit tools, and instead of typing union, I type difference, select the other tube, and it'll say, do you want to delete your input, yes or no? In our case here, we want to delete the input, which would be what we're removing. Click yes, hit enter, and what it does is actually removes the area that's taken up by the second piece of tube. And now you can see on the screen The process happens on its own. The command is awesome. I use it for all kinds of things. I'm about to use it again. I'll show you in a minute. But now, those frame rails are now hollow 2x4 8th wall box tube. This is now an accurate representation of what we're working with. The box tube I'm planning to use is going to have a sharp corner. It's probably going to have an 1/8 inch outer radius. It's not going to be sharp, but some of, the thicker wall box tubes have quite a big rounded corner on them. The 8th wall 2x4 tends to be a fairly small radius. So I'm building my pieces to that. If I have to shave things down here, I will. But for what we're doing here, this is going to work out just about perfect. I'll be able to grind the weld to the same contour as it. Now you can see here those outer frame plates. You can see how they don't touch the box tube there. That'll be our weld area. What I'm drawing here is I've gone into circle and I've selected cylinder. Just another solid tool. It's just like our box. Now we know we need plug welds, but being that those are going to be inside of the box tube, a plug weld on the inside isn't going to be very helpful. We won't be able to access it. So we'll plug weld these on the outside. Our inner fish plate will be solid, and our outer box tube will have the holes. So what we're doing now is I'm actually copying that same solid to the lower plate, and we need a plug weld in the middle of this box tube as well. So all I'm doing is drawing a line so that I can copy that piece from the center of that to the center line that I just drew in on the box tube. There we go. Now we're going to select all three of our box tubes. We're going to go to solid, edit tools, difference, delete input yes, and we're going to click all three of these tubes. And now, as you can see, this is what I was talking about, how it can be handy in other ways. All of our box tubes have a hole for our plug weld, just like that. Now, I can take this piece, and you can see that it's been moved in 1/8 of an inch so that it's inside of the frame rails. That would be as far out as that piece is going to go. So I know that I can go up into, I can extrude this. Hopefully the next time I do one of these videos, I figure out how to bypass the menu that don't show up. But if we go up into our controls, we can go solid, extrude, linear, and we're selecting 0.125 or 1/8 inch as our thickness. We can go out to both of our outer plates. We can select the same 0.125. Now our inner fish plate is smaller than our outer plate. And you can see here we have our weld gaps. We can have our plug weld holes. And from the side, visually, the only thing that's missing is the top and bottom plates that take up that last 1/8 of an inch. Now, this is virtually as far as I really need to program. The thing is that I can go through, I can select lines, and I can select length. It's kind of weird programming out these pieces because Rhino doesn't like to flatten out pieces on a curve, or if it does, I haven't figured out how to do it, and honestly my way is a little bit faster. Mirror these pieces, and now with the three-dimensional view, you can see the outside plug welds on the closer side, you can see the inside plug welds on the other side. That's essentially how the frame rail is going to function. Now, I've gone back to the model, I've deleted all of the old stuff, and that'll give me the opportunity that I can slide all this back. We know that it was 100 inches from the frame, so when I pull it back 100 inches, it's going to be in the same place that I removed it. But you can see along the cursor here, I'm showing the edges. We're missing a top plate. We're missing bottom plates. So on that section of frame rail, we're missing 4 pieces of plate. So Control Z undoes my delete because that frame rail hadn't been modified at all. So what I'm doing is I'm moving that frame rail forward 100 inches. It lines up. I'm going to delete all of my excess pieces here. I've deleted my extrusions. That's the side of the frame rail that I did not offset my lines yet. So those lines are still the same as they were before. And that's what I need, is I need those full outside dimension lines, because what I'm doing here is I've hit the explode command. I'm removing all of the vertical lines because we're not making a side plate anymore. If I click on a line and I type in length, hit enter, in the top left you can see the measurement pop up. It shows me exactly how long that line is. So that means for our filler plate that goes across the top, I know that it has to be that long. I know that it needs to be 1/8 of an inch shorter on either side than our frame rails, so 1/4 inch subtracted from 2 inch, so that length, and 1 3/4 inches wide. So when I cut this plate out on the plasma table, all I need to do is program out a flat rectangle. I have my dimensions, and I can shape it over a tube. I can shape it with a mallet tacked up on the frame. I can do a lot of things. What I'm doing here is I'm just selecting each line. I'm offsetting it 0.125, and I'm going to go back in with my line draw tool, and I am connecting the dots. I'm basically filling this in because the software doesn't want to extrude what isn't a closed box. It will give me a flat panel if I extrude a line, but it doesn't replicate what the metal will be once it's formed. So this is the quickest way I've found to do this. I already know what my dimensions are when I program this out and break it down to be cut on the machine. I know what I need to do, but for visual purposes, it's nice to have that piece there so you can stare at it and realize what's going on. Select all my lines, type in join, hit enter, and we know that if we take those lines and we extrude them, that's going to be our plates. So right now, I need to get them from that side of the frame to the other side of the frame. So what I've done is I've grouped everything together there. The nice thing is that by grouping it, I can't accidentally select one part. I've mirrored those lines, and now when I select from the top, all I'm doing is selecting those lines. Now you can see that those lines line up to the outer edge, and we need them in 0.125 to replicate where the tube would be. Therefore, the only thing that we're not showing on the model is our weld. I don't bother modeling in the weld because it's a nice reminder that the weld is going to exist. And we go up into our solid, extrude straight, and we know that we want to extrude this 1.75 inches, as I talked about. And now, with that extrusion done, select everything. If you left click on the magnifying glass, it will zoom in to what's highlighted on just the window you're on. If you right click, it actually zooms into what you have highlighted on every window. Super handy tool. The one beside it is Zoom Extents, which is zoom in on everything in the entire file. I use both of them regularly because that allows me to zoom in where I need to be. I can click on one spot and it takes me there. Now that this frame rail is done, I move it back over my 100 inches. We can go in and we can mirror it off of our cross member, which is a good known center point. And if we go back out to our perspective view here, oh, there's Zoom Extents to all windows. And on our perspective view, our frame rail exists. We zoom in on just our three-dimensional view, and we can see all of our weld seams. We can see all of our plug holes. We can see our stacked plate through the holes in the frame. Everything the way it's going to be. This is what it should look like in real life, plus the weld that I need to add. And of course, I like to spin it around and stare at it. I'm not going to lie, I do a lot of this for fun as well. There's been days where I've just sat down and I've programmed things just because I want to program things. So I skipped ahead so you don't have to see it all over again. I went in and I did the exact same process to the back. Now, if we go into our three-dimensional view here, you can see the exact same thing. I've got my plug welds in the frame. I've got all of my pieces. I have my multiple layers of plate. You saw the entire process in the front. The video is already dragging on. I don't want to put everybody through that and have everybody run away before you see it finished. but I wanted to be able to finish this out. You can see along the rocker there where my clicker is. We're going to have rooms for, say, 3 body mounts per side. I can use a nice thin universal mount. We've got our cross member. It wraps over the axle. We've got a roll bar, door bars, and this is how it sits. And if I get rid of the tire layer, I mean, we can see the radius that tucks inside the body. The radius kind of matches the brake rotor dimension. I mean, it's all about being pleasing to the eye, and we're never going to see most of this until I open the trunk. The fuel cell's got to go back there somewhere. We need a battery, but this is kind of where we're at. I'm probably going to do some big fender dump headers here. This whole visual thing is such a good tool for planning ahead. And if I take that and I use the original picture that I pulled out of the intro video, this is what we end up with. And this is one of my favorite things to do because this is what I envision in my head. Super cool to be able to do this. But this is where I'm going to leave this off. If you enjoyed this, do me a favor, subscribe to the channel, like the video, comment below, and I'm out of here. We will see you next time.